defined as R is equal to an ordered pair A comma B such that A is less than or equal to B square. A is less than or equal to B square is neither reflexive nor symmetric nor transitive. We need to prove that the given relation R under real numbers under the given condition A is less than or equal to B square is neither reflexive nor symmetric nor transitive. This is what we have to prove in the first question. In the second question, we need to check whether the relation R is R in R defined by R is equal to an ordered pair A comma B such that A is less than or equal to B cube is reflexive, symmetric or transitive. In the second question, we need to check whether the given relation is reflexive, symmetric or transitive. I hope you have got an idea for both the questions. The first question is to prove that the given relation is neither reflexive nor symmetric and not transitive. And in the second question, we have to check. Since I said in the beginning itself, for both the questions we have same solution, which means for both A less than or equal to B square and A less than or equal to B cube, we can say that both are neither reflexive nor symmetric nor transitive. How it is not? Let us see with a counter example. So for the first sub question, when the relation R is equal to, or whether it is for the first question or the second sub question, both I am giving the same answer. Okay, let us cross check for reflexive. So here, since they are saying that under real numbers, if you take integers 100%, it will satisfy. 1, 1, 2, 2, 3, 3, 4, 4. If you take like this 100%, it will satisfy. Since it is real number, we need to check in a different way. So let us take fractions here. So if I take 1 by 2, 1 by 2, the given condition will not satisfy. I'll let you know how it is. 1 by 2, 1 by 2 belongs to R. If I say the condition is given very clearly that A is less than or equal to B square is given. 1 by 2 is less than or equal to 1 by 2 the whole square we will get. Value of 1 by 2 is 0.5 is less than or equal to 1 by 2 the whole square is nothing but 0.5 the whole square we will get, which is nothing but 0.25. Here 0.5 is lesser than 0.25. Yeah, it is. So here the given condition is not satisfying because 0.5 is not lesser than 0.25. Actually, the 0.5 is greater than 0.25. Since the condition is not satisfying, therefore we can say that 1 by 2, 1 by 2 does not belongs to R. Therefore the relation R is not reflexive. Finish. Clear? For both the question we can consider the same. This is for the first question. I will write the solution for the second question here. If 1 by 2 is not less than or equal to 1 by 2 the whole square, does 1 by 2 is less than or equal to 1 by 2 the whole cube? No, not at all. So here also we can say 1 by 2, 1 by 2 does not belongs to R. Therefore, R is not reflexive. Finish. We have proved that the given relation is not reflexive because 1 by 2 is not less than or equal to 1 by 2 the whole cube. Clear? Now moving to the next one, that is symmetric. When do we say that the given relation is symmetric? To say that the given relation is symmetric, if A comma B belongs to R, then B comma A should belongs to R. So I will take one counter example to say that the given relation is not symmetric in both the cases. For example, if I take 1 comma 2, I can say that 1 comma 2 belongs to R because 1 is less than or equal to 2 square, which implies that 1 is less than or equal to 4. That is true. Okay, but if I take its reverse as a 2 comma 1, does 2 comma 1 belongs to R? Let us cross check. 2 is less than or equal to 1 square, which implies that 2 is less than or equal to 1. Is it true? 2 is not less than or equal to 1. This is false. Okay, this is false. 2 is not less than or equal to 1. 2 is not less than or equal to 1. So we can say that 2 comma 1 does not belongs to R. Very simple. 1 comma 2 belongs to R and 2 comma 1 does not belongs to R. Therefore, R is not symmetric. Similarly, here also under the condition for the condition A is less than or equal to B cube, also I can prove the same. 1 comma 2 belongs to R, which implies that 1 is less than or equal to 2 cube, which is 1 is less than or equal to 8. That is true. But if I take the reverse of this 2 comma 1, I can check that 2 is less than or equal to 1 cube, which implies that 2 is less than or equal to 1 we are getting. 2 is not lesser than or equal to 1. So we can say that 2 comma 1 does not belongs to R. When you are writing in your examination, only if you write this much, that is sufficient. 1 comma 2 belongs to R. but 2 comma 1 does not belongs to R. Therefore, the relation R is not symmetric. Better you write only so much. Even here also we can say that same for A is less than or equal to B cube. 1 comma 2 belongs to R and 2 comma 1 does not belongs to R. Therefore, R is not symmetric. R is not symmetric. Now the condition will come for transitive. Many students will struggle to remember the same or to give a counter example for transitive relation. To say that the given relation is not reflexive, not symmetric, not transitive. I am giving one single solution for both the questions. Single solution for both the questions. Whether they are giving A is less than or equal to B square or A is less than or equal to B cube. Never worry. Write the same solution for both the question. You will get full marks. So let us see what is that solution. When do we say that the given relation is transitive? If A comma B and B comma C belongs to R, then A comma C should belongs to R. That means we should take the two ordered pairs, which is in the form of A comma B and B comma C. And we need to prove that A comma C does not belongs to R. Then only we can say that the given relation is transitive relation. So here I am giving one simple ordered pair. Remember this: 4, 2 and 3 by 2. Take these three elements. These three elements are in a decreasing order. 4, 2, 3 by 2 is nothing but 1.5. 4, 2, 3 by 2. That means these are the values of A, B and C respectively. Okay, A, B, C respectively. Now we need to take the two ordered pair in such a way that A comma B and B comma C should belongs to R. The condition should satisfy. So I am taking 4 comma 2 belongs to R and 2 comma 3 by 2 belongs to R. What does it mean? It means that 4 is less than or equal to 2 square, which is true. Again here 2 is less than or equal to 3 by 2 is nothing but 1.5. 1.5 the whole square. You should know the value of 1.5, then only you will get to know whether 2 is really lesser than or equal to 1.5 the whole square or not. The value of 1.5 the whole square is 2.25. Okay, so which is true. Again here also we can say it is true. 2 is less than or equal to 2.25. This is also true. That means we can say that 4 comma 2 and 2 comma 3 by 2 are belongs to R. Which means here our ABC value are 4, 2, 3 by 2 respectively. A comma B and B comma C. We have A comma B and B comma C. But now we need to cross check whether A comma C is belongs to R or not. But we need to prove that here A comma C does not belongs to R. Then only we can say that the given relation is not transitive, because the first question was given very clearly to prove that the given relation is neither reflexive nor symmetric and not transitive. Accordingly, I am trying to prove. Now I will take the value of A and C as 4 and 3 by 2. 4 and 3 by 2. Now cross check whether this A comma C is it belongs to R or not. Now I will check the condition for A is less than or equal to B square. 4 is less than or equal to 1.5 the whole square, because the given condition is A is less than or equal to B square is given. Now if I cross check, the value of 4 is less than or equal to 1.5 the whole square. What is 1.5 the whole square? 1.5 the whole square is nothing but 2.25. Clear? 2.25. So from this it is very clear that the value of 4 is not lesser than or equal to 2.25, which means 4 comma 3 by 2 does not belongs to R. Therefore, the relation R is not transitive. Therefore, the relation R is not transitive relation. Clear? I hope you have understood. And I will explain now for A is lesser than or equal to B cube. Now, as I told you, the same solution for both the questions. Now, I am proving for A is less than or equal to B cube. Same ordered pair you can consider for transitivity. For A is less than or equal to B cube. Okay. So, here I will take 4 comma 2 belongs to R and 2 comma 3 by 2 is belongs to R. Okay, what does it mean? It means that 4 is less than or equal to 8 because 2 cube, which is true. Similarly, 2 is less than or equal to 3 by 2 the whole cube. 3 by 2 the whole cube is nothing but 1.5. 3 by 2 is 1.5. 1.5 into 1.5 into 1.5. If you multiply 1.5 3 times, you will get 3.375. You will get. If you want, you can cross check. And it is very clear that the value of 2 is lesser than 3.375, which is true. Okay. And now I need to cross check whether A comma C is it belongs to R or does not belongs to R. Our intention is to prove that it is not belongs to R. I will let you know how it is. Now I am taking 4 comma A comma C ordered pair. 4 comma 3 by 2. So this implies that 4 is less than or equal to 3 by 2 the whole cube, 3 by 2 the whole cube, just in the previous step only we had written, that is 3.375. Now you tell me, does 4 is lesser than 3.375? No, 4 is greater than 3.375. So we can conclude here very clearly that the value of 4 comma 3 by 2, this implies that 4 comma 3 by 2 does not belongs to R. Clear? Therefore R is not transitive relation. I hope you have understood. This is one of the easiest solution, my dear students. Even when I was learning this particular problem in the beginning, I used to think very much and I used to apply. I used to take my own example as 1, 2, 3 or something and all, and I used to waste my time like anything. But I suggest you, never waste your time and never do error and trial method in your examination, because in our examination we have only 3 hours. We need to utilize that 3 hours in a proper way. So that means we have to be prepared for these type of problem in advance. So when we have a is less than or equal to b square and a is less than or equal to b cube, be prepared with the solutions that if you take the value of a, b, c as 4, 2, 3 by 2 respectively, 100% you can easily prove that the given relation is neither reflexive nor symmetric nor transitive.